All right, guys. Questions on 1, 2, or 3, and what are these in particular that y'all want to look at? 1. Cosecant of x equals -7/6. Tangent is greater than 0. So since cosecant of x is -7/6, well, cosecant is just 1 over sine. So that's telling us sine of x is equal to -6/7, because it's just 1 over that. Now we can find cosine next. Now there's different ways to find it. One, we could set up the triangle to do that. So we can put it in the quadrant, our 4 quadrants. So we know tangent's positive. Tangent's positive in 1 of 2 places, the first quadrant or the third. That's the only 2 spots where tangent's positive. Now we know sine is values negative. Sine is only negative in the third and fourth. So that tells us this triangle has to be in the third quadrant for our angle x here. Sine is opposite over the hypotenuse. Now to find the other side, we're going to use the Pythagorean's theorem. A squared plus our b value, which is -6, is equal to c squared. Now our -6 squared is going to be 36. 7 squared is 49. At this point here, we can subtract 36 from both sides, telling us that a squared is equal to 13. Square root both sides, so a is equal to plus or minus the square root of 13. So the other side of this triangle is the square root of 13, but since we are in the negative x-axis, the value of this would be negative square root of 13, because we're on the negative side. And now that we have this set up, we can actually find cosine of x, because cosine is the adjacent side, which is negative square root of 13, over the hypotenuse, which is 7. Now that also helps us find secant of x, because we're going to flip this. It's going to be 7 over the square root of negative 13. Well, we're going to need to plug this into the calculator. Let 30xs simplify our radicals, because we can't leave a radical on the bottom of the fraction. So it tells us it's -7 squared root of 13 over 13. So we've found 4. The only 2 that we have left are tangent and cotangent. Now tangent of x is going to be the opposite side, which I'll write this one out because we'll have to fix it. Negative square root of 6 over the adjacent negative square root of 13. Now we'll have to type this in the calculator because the main thing is that we can't have a radical in the bottom of a fraction, which does simplify to 6 squared root of 13 over 13. And as the problem stated from the beginning, this is positive, and our tangent value is indeed positive, and that should be 13. And lastly, cotangent of x is just the flip of tangent. So there's 2 ways we can go about doing this. We can say, plug in that this is 13 over 6 square root of 13, which is just square root of 13 over 6, or just flipped it from the one before. Questions on how we found, well, 5 of the 6. The 6th one was given to us from the beginning. Questions on this here? And we'll do 1 through 3 the exact same way. Questions on these here? Four through 7, factor each expression. I'll be posting the ones we do because most of these here factoring is not even going to show up. Yeah, so if I told you not to do them, they're not going to show up on the test. Yep. Questions on 22 or 23? One of these that y'all had issues with. 23. 3 cotangent squared of x minus 1. So here there's different ways we can go about doing it, but since we just have cotangent squared as the only trig function, we can get it by itself. So the first thing we can do is add 1 to both sides, which tells us that 3 cotangent squared of x is equal to 1. Still need to get it by itself, so we can divide both sides by 3, telling us that cotangent squared of x is equal to 1/3. And lastly, to get cotangent by itself, we're going to take square root of both sides. Now the nice thing with our cotangent squared is when we take the square root of it, it's just going to become cotangent of x is equal to plus or minus. Now we need to take the square root of 1/3. 30xs will do it, but we just have to split it up to the square root of 1 over the square root of 3. Which is telling us that cotangent is equal to plus or minus the square root of 3 over 3. Now, cotangent we do not have specifically written out on the unit circle. We could go about finding it since cotangent is x over y, so we'd take the x value of each point and divide it by y. Or we can use our reciprocal functions and know that since cotangent of x is equal to plus or minus the square root of 3 over 3, well, tangent's 1 over, we would flip it, which would be 3 over the square root of 3, 3 over the square root of 3, which is just telling us that tangent of this same angle would be plus or minus the square root of 3. They're going to have the same value, the same angle. Now, luckily for us, we do have that list out on our unit circle. It's not specifically on the circle, but it is on that reference page. And it tells us that tangent equals the square root of 3, positive square root of 3 at pi over 3. And since we want the positive and negative, we'd actually get all of those. We're on the unit circle, so here. Well, pi over 3 is this positive angle for tangent, where tangent of pi over 3 is our square root of 3. Pi units away from it on the other side, tangent of this angle is also the square root of 3. And the one that is that angle is 4 pi over 3. So tangent of x equals square root of 3, positive square root of 3, at pi over 3 and 4 pi over 3. But it didn't want just the positive, it also wanted the negative square root of 3, where tangent of an angle is equal to the negative version of it. And again, What was our denominator for the first two? 3. So tangent would also be, here is 2 pi over 3, and then 5 pi over 3. And since it asked it, and on the test it's just going to ask you between 0 and 2 pi, we get these here. Now the nice thing with tangent and cotangent is when pi over 3, especially the plus or minus a value on the unit circle, we just take all of them with that same denominator. Questions on this one here? Questions on how we got to this answer? Now if it had just been negative square root of 3, tangent equals negative square root of 3, we're just taking the 2 pi over 3 and 5 pi over 3. If we want just the positive, it would be our pi over 3 and 4 pi over 3. Okay. Questions on 22? Questions on 24 or 25? 25? So secant squared minus secant of secant equals 2. Well, the first thing we're going to need to do is get this equal to 0. So we'll subtract 2 from both sides. Telling us secant squared of x minus secant of x minus 2 is equal to 0. And at this point, we can factor this here. Since there is no greatest common factor between these three terms, we'll set up our two sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Now the factors of the first term, secant squared as well, just going to be secant of x and secant of x. Our factors of 2 are, well, 1 and 2. Which one do we want to put first? 1 and 2. And these are indeed the correct factors, because secant times negative 2 plus secant will give us our negative secant of x. Now at this point here, we have 2 or more things multiplied together to equal 0, so one of them has to be 0. So we're saying that either secant of x plus 1 is 0, or secant of x minus 2 is 0. And we're going to solve both of these for secant of x. So we get that secant of x equals negative 1. And here we get that secant of x is equal to 2. Questions on how we got to this point here? Now secant of x is not on the unit circle, but secant is the same as 1 over cosine, or cosine of x is equal to 1 over, we flip it. Well, if you flip negative 1, you just get 1 over negative 1, which is just negative 1. Now for our secant of x equals 2, if we flip 2, we get 1/2. Which is a little bit nicer, because now we can look at the unit circle and find our angles. Because on the unit circle, cosine is our x value, and we're looking for where cosine is -1 between 0 and 2 pi, which is just pi. Pi is the only value. And since we're stuck between 0 and 2 pi, we do not have to add the 2 pi in. We don't have to add the period back to it. Now cosine of x equals 1/2, so we're going around the unit circle looking for where the x value is 1/2. One of them is pi over 3, the other is 5 pi over 3. And that's it. Because the other two pi over 3s, 2 pi over 3 is -1/2 for cosine, and 4 pi over 3 is -1/2 as well. So if we're looking for positive -1/2 for cosine, we actually get all of our pi's over 3. Pi over 3, 2 pi over 3, 5 pi over 3, 7 pi over 3, or 5 pi over 3, 4 pi over 3, not 7 pi over 3. But that's it. Questions on this here? Okay. Questions on 24? Questions on 26 or 27? 26 or 27? 26. Cosine of x plus sine of x times tangent of x equals 2. Two things. One, we need to first try to get this all in terms of sine, cosine, tangent, secant, cosecant, cotangent. We need it all in one. So having the sine and tangent is causing issues. And since they're not squared, we can't just replace it with one of our trigonometric identities, our Pythagorean identity. But, all right, guys, let's focus in. Tangent can be rewritten in terms of sine and cosine. And tangent's what? Sine over cosine. Tangent sine over cosine. And we can multiply these together to get sine squared of x over cosine of x is equal to 2. Questions on this here? Questions on anything we've done so far? Now at this point here, there's different ways we can go. We can try simplifying that fraction as best we can, or we can try getting rid of the fraction entirely. Because if we get rid of the fraction entirely, to do that, well, I would need to multiply this by cosine of x. As we'd have cosine of x over cosine of x, and those would cancel. But I can't just arbitrarily multiply the middle term by cosine of x. We actually have to multiply the entire equation by it. We're scaling it up by a factor of cosine of x. Now the middle term ends up getting a little bit nicer since cosine of x canceled. We're left with sine squared. On the right-hand side, we now have 2 times cosine of x, which is 2 cosine of x. We do have one other term. It's our cosine of x times cosine of x, which gives us cosine squared of x plus sine squared of x is equal to 2 cosine of x. Questions on this so far? there is one thing that works out very nicely with this here, and it comes from, I'll get a highlighter, this statement here. Because the Pythagorean identity that we had, I'm going to rewrite it here, says that cosine squared plus sine squared is equal to 1. So that's just one of our Pythagorean identities, which means the entire left side of this equation is what? Yep. You're allowed to use the reference sheet for the test, that reference page, which has all the equations. I'm not expecting you to memorize all those on the test and your unit circle. And that's really nice that that works that way. The fact that multiplying by cosine gave us the cosine squared plus sine squared, was simplified to 1, because now how many trigonometric functions do we have? 1, and it's just cosine. I don't have anything else. So we can just solve. We can divide by 2, telling us cosine of x is equal to half. And I know we can do our cosine inverse, but I just grabbed the unit circle, because using cosine inverse will indeed tell us that cosine of x equals 1/2 at pi over 3. But that's not the only value that gives us 1/2 between pi 0 and 2 pi. We also have 5 pi over 3. We need both. We'd have to do other calculations to find the other one if we use the calculator to get it. But the unit circle just straight out tells us which two they are. Which one are you looking for? Oh, factoring. So these two, do this and then solve it. If you're completely stuck, you can do it, solve it other ways, but it's just the 1 or 2 points for factoring you'll lose. Does that make sense? You'll still get answers for answering it correctly. It's just those two. But if you're not sure, hit the rest of them, come back. Especially for graphing. Graphing's nice. Essentially, like the last two, get them to there and solve it the same way. Or the page before. Get them there, solve. Does that make sense? Questions on 26 or 27? Questions on 28, 29? Cosecant of x plus cotangent of x equals 1. Cosecant sine. Okay. Now there's different ways we can get to this, because there's properties. I mean, we could try to use the square. We square both sides, that we can use the Pythagorean identities. That cotangent squared plus 1 is equal to cosecant squared. Or we can turn it into sine and cosine. That'd be cosine over sine. Yeah. I have a feeling we're going to end up having to square anyways. So since we're going to square this, and the reason I say square, so I'm going to write this out. You don't have to write this down. Cosecant is 1 over sine of x. Cotangent is cosine of x over sine of x. Well, since the denominators are the same, we can add it. And we get this here. Well, there's many different ways for us to get 1 plus cosine of x over sine of x to be 1. Because it's going to depend on sine of x and cosine of x. Actually, we can, yeah, that'd work too. I mean, at this point here, then we can multiply by sine of x, but then we have to square it to get there. The other option is to move cosecant or cotangent to one side. Doesn't matter which. I'll let you all pick. Cosecant or cotangent? Cosecant. So what we're going to do is minus cosecant of x from both sides, which will tell us that cotangent of x is equal to 1 minus cosecant of x. And at this point here, we're going to have to square both sides because we want to use the Pythagorean identities. But that also means we're going to have to come back and check and make sure our answers work. Now, cotangent squared as well. Cotangent squared of x. Since there's only one term, it just be multiplied by itself. Now, 1 minus cosecant of x, we're going to have to square it. We're going to have to multiply it by itself. So we're going to have 1 minus cosecant of x times 1 minus cosecant of x. One times 1 is 1. We're going to minus cosecant of x minus cosecant of x. How that written. Just cleaning it up. Cosecant of x, negative cosecant of x times the negative cosecant of x is going to be positive cosecant squared of x. And once we combine like terms, we have cotangent squared is equal to 1 minus 2 cosecant of x plus cosecant squared of x. Now, if we look at the Pythagorean identities, one of them that we have is cotangent squared plus 1 is equal to cosecant squared. So we can use this here to help us solve. Now it's tempting because we can just type in, replace cotangent or cosecant here with cotangent squared plus 1, which does give us cotangent squared on both sides. That's fine, but we also have a cosecant to the first power. We would have two different trig functions. So we can't necessarily just use this as it is. But if we subtract 1 from both sides, we get that cotangent squared is equal to cosecant squared minus 1. This is more helpful because if we replace this cotangent with cosecant squared of x minus 1, we now have an equation entirely in cosecant. Where if we'd changed the cosecant squared, we would have had cotangent on both sides, but we would also have a cosecant. We have two trig functions. We need it in terms of one trig function. Now at this point here, we do need to get this equal to 0. First thing I can do is add 1 to both sides. And we can also subtract cosecant squared from both sides. Now that will give us 0. 1 plus 1 is 2, minus 2 cosecant of x. Cosecant squared minus cosecant squared is, so 0 is equal to 2 minus 2 secant. Finished. Yeah. You can stay here till the bell. Now we just need to get cosecant by itself. Well, the first thing we can do is, what? Subtract 2. Telling us negative 2 cosecant of x is equal to negative 2. Now this seems a little backwards. Why did we add the 1 and then move it back over? Part of the reason we added 1 was just in case we did have a quadratic, we'd have to factor it, so we would need the 1 over. Well, the squares canceled out. We don't have a quadratic. Now we just need to solve. Now this tells us that cosecant of x is equal to 1. Now cosecant of x, again, is not on the unit circle, but its reciprocal function, sine, is 1 over cosecant. So 1 over 1 is, well, 1. Unit circle. So we need to find out where sine of x is equal to 1. Well, that is pi over 2. Now, 1 and negative 1 are the only ones between 0 and 2 pi where sine and cosine have a singular value, or just 1 and negative 1. Because sine is 0 at 0 and pi. Cosine 0 at pi over 2 and 2 pi. But sine is positive 1 at pi over 2 and negative 1 at 3 pi over 2. Cosine is positive 1 at 0, negative 1 at pi. 1 and negative 1 are the only two that it only shows up once between 0 and 2 pi. Questions on this here? Does this make sense how we got there? Kind of, sort of. Yeah. And again, when in doubt, I would change it to our sine and cosine. Just because it's not the way that we did it here, and you could see it going another way, that's perfectly fine, because we could have kept going from here and just squared both sides. And the left side would have been 1. The denominator here would have been sine squared of x. I'm going to skip some steps in between. Because if we multiplied the numerator, we multiplied cosine of x plus 1 by itself, we would end up getting cosine squared plus 2 cosine of x plus 1. Now to get rid of the fraction, just like we did on the previous one, we'd have to multiply both sides by sine squared of x, because these would cancel, telling me that I have cosine squared of x plus 2 cosine of x plus 1 is equal to sine squared of x. Now at this point here, we can change sine squared into cosine squared. And this would be 1 minus cosine squared of x. This all is going to become 0. That becomes 0, telling us that we have 2 cosine squared of x plus 2 cosine of x We'll have to check pi over 2 in a minute. We can factor this here and solve, telling us that 2 cosine of x times cosine of x plus 1 is equal to 0. So we either have that cosine of x is equal to 0, or cosine of x plus 1 is 0. Now cosine of x equals 0 when x is equal to pi. That's the only one. Well, sorry, not pi, pi over 2. And 3 pi over 2. I was thinking of the other one. And cosine of x equals -1 at pi. Now if you notice here, we do have 2 other angles, 3 pi over 2 and pi. Let's look back at the top. Three pi over 2 and pi. Cosecant of x, cotangent. So cosecant of x is our 1 over sine of x plus cosine x over sine of x, and we're trying to see where this is 1. Make sure that calculator's in radians. So let's check this here. 1 over sine of pi plus cosine of pi over sine of pi. We should get 1. This says divide by 0, which is telling us that sine is 0 at this point, which means for us pi is out. It doesn't work. It's a false statement. It's not going to work. Anytime we square both sides, we really need to check our solutions. We can check pi over 2 next. So we say pi over 2. Pi over 2. Pi over 2 is 1, so that works. And the only other angle we got, especially from the last one we did, was that our angle was 3 pi over 2. Okay? And I think I know what we're going to get here. Division of 0, or -1. Because either division of 0 or -1. But we want it to be what? +1, not -1, so 3 pi over 2 is. So the only one that actually works is pi over 2. Now, I think y'all noticed something between those two ways, yes? They both gave us the right answer. There's different steps, different procedures. One's longer than the other. This one gave us, second method gave us 3 answers. 2 of them didn't work, so it's just the one. And the first method just gave us the answer. So sometimes they're different. Some are easier than others. But the biggest thing I would say with any of these is whichever one you see first, go for it and do it. I wouldn't second guess yourself. Go through it, do the method, and try to get to the answer. Because the biggest thing with this test is if you don't, you're going to spend too much time second guessing yourself and get yourself in a knot. And by that point, you're so second guess yourself out of it, you're going to just get stuck. I would trust your gut, trust it, and just go. All right? All right, we're going to keep looking at these tomorrow because we're about out of time.